Okay, I'll be starting in 2 minutes. Okay, so today I'm gonna cover what are different types of object detection models and how can you construct an image-based 3D object reconstruction. So what is 3D object reconstruction? Is it basically when you take an image and how can you process that image to make a virtual 3D model? And we will discuss what are some techniques and like different techniques have different like approach to do that. So we'll go through those techniques. Okay. One second. Yeah, so I have created this Miro board. So if you want a link, it's uploaded on my GitHub. Mm, so in this, you'll find this board link if you want to follow along. All right, so let's first discuss what are what are these terms. So basically, image classification will take an input image and give you the major dominant object in those images. So nothing fancy, just will give the text description. And object detection, what those models do is they give you bounding box for those objects. And you might have heard of semantic segmentation. So it's a pixel-based differentiation of those objects with the background. So hence you can see different colored objects. And there is instant segmentation. So it's a combination of uh, semantic segmentation plus it also gives some object information. Right. So in in object detection, there are two major approach to solve that problem. And basically they are classified in one stage detector versus two stage detector. So what one stage detector do is they propose a region based uh, focus ROI, region of interest in the first stage. Then they focus on object detection on that particular region in the second stage. And as you can see in this image. And so that is two stage detector. For one stage detector, it's doing everything in one single shot. So it will do object classification and object detection in one stage. Hi, Naman.
Hello, Mayur. How are you?
I'm good. How are you?
I'm doing great. Thank you for taking out the time, and you're doing amazing work.
Thanks. Yeah. So I'll just give you an overview what I was sharing. So today's topic is focus on 3D object reconstruction. So basically, we'll be discussing those models from which you can take image in real life and construct a virtual 3D model just from those image data. And uh, few of the major computer vision models available till date is the image classification, where we just uh, find the dominant object in that image, and it uh, that's the output of those models. Localization gives you bounding box. Segmentation gives you pixel-wise differentiation between various objects. And instant segmentation has data of what kind of objects are there, as well as the pixel differentiation.
Mhm.
And basically, for object detection, there are two approaches. One is based on your image, you find a region of interest. A region of interest is basically a bigger box on that image where you'll focus on object detection. So if you have like this kind of dog or even a small object, so there would be different region of interest where there would be a bigger pixel area around that object, and the next step would be to accurate bounding box based on that region. And second is one stage detector, where you do both classification and detection in one stage. So the reason one stage detector got popular was because uh, it has relatively lesser computation time compared to two stage. And there are many applications of this kind of models where if they want to do real time object detection and classification, they want models which has lesser computation time. Hence, this kind of model got more popular. And if you have higher computation and your focus is on accuracy, then you will prefer this two-stage model. So this is a basic overall summary how the trend was, where AlexNet was the first classification, and then YOLO. YOLO is, I think, is a single shot detection where you see object once, and similarly SSD, single shot detection. So these
Mhm.
are the models in one stage. These are various models in two stage. So currently, RetinaNet has proven to be the best among all the single shot models, and Pyramid and Faster RNN are popular among two stage. Okay, so yeah, let's. Our focus is on 3D reconstruction. So we don't want like what's there in the image, because we can definitely get those from object detection, which has image classification plus bounding box. So um, few things on two-stage detection is like they initially XCNN, which is convolutional neural network, are pretty good in determining the shapes and overall objects in the model. Then they proposed RCNN, which is region-based CNN, which focuses on various regions in the network. Then they tweak a few parameters to make fast and faster RNN. Basically, that replaces some ROI, region of interest pooling technique, and decreases the computation as well as increases the accuracy. And these are some semantic segmentation models, instant segmentation, and LiDAR bits. So this is one thing which is getting more popular because, as you may have noticed, Apple released LiDAR sensor in their new model. So basically, in these models, what they used to do is once you have image, they did pre-processing to find the depth map in those images, because it, ultimately we want to construct a 3D model. So we want to know the distance between various objects from our source. So there were various depth map models which were applied on this models to get the distance. But the advantage with lidar based is it gives not only gives the image but also depth data from that capture. So it increases the accuracy using those inputs compared to just images. So a popular models are Point CNN, PointNet, and VoxelNet. So yeah, I'll just quickly run through what are some models or techniques for 3D construction. So as I said earlier, this is RGB 2.5D. So it takes not only RGB data but also depth map and do 3D reconstruction. Then the next technique is voxelization. So based on a voxel grid, they will determine whether the object is present or not, like occupancy data, and then they'll remove all those voxels which doesn't have the object, and it will result in final 3D object based on that. Next is multi-view projection. So basically, you will take multiple views of the object, and based on that, it will reconstruct the 3D model based on those images. And next is point cloud data. So uh, as I said earlier, from the Apple LiDAR scanner, there's a feature where they also provide point cloud data with ARKit. So you can definitely use that 3D data and perform segmentation classification technique based on that data. And another recent trend is using graph neural network, where basically you have different nodes and each node carries features, and you do deep learning technique uh, based on your problem on those features. And I I think CNN and graph are related in a manner that in convolutional neural network you like process a sliding window, and all the, let's say if it's a 256 by 256 pixel image, all the small pixels have edges and data, and you can derive relationship from those adjacent pixels. Similarly, in graph, it's connected via this edges, so you know how eyes are related to nose, and so you can derive those relationship via this nodes and edges. So that is currently a hot topic in research using graph. Yeah. So as you can see, RGB plus depth generates point cloud. There's a point cloud plus occupancy grid generating 3D neural network. These are voxelization technique, 3D multiple projection. Yeah. And this is graph neural network where you combine this data with CNN. Okay, so let's summarize. So we saw single shot detection, like single stage detector, which are popular models where YOLO and SST. And the difference between them is in YOLO, you just have one convolution, and these are the bounding box. Whereas in SSD, you have multiple convolution, and you you extract features from each layer when you're doing the network test. So you can see the extracting features at different scales using that. So yeah,
Mhm.
these are two stage and these are one stage. Do you have any things you wanna clarify?
No, no.
Awesome. So we have now got a bit like overview about what are various object detection, 3D reconstruction models
Yes.
available for us to deploy. And
Yes.
yeah, also it's important when you are developing a new model or doing research that what are some existing data sets you can use for your custom training. So for example, if you are, let's say, if you want to do a deep learning model for MEP pipes detection, so the models here used are trained on pretty generic objects where, and you want to do the next step you want to do is using those models and do a custom training. So what you will do is uh, take a particular model, then do labeling that this is MEP pipe, and then you will do your own bounding box, and that data is like what's the width, height, center of the MEP pipe, and what kind of pipe is it is. So depending on your problem, you can do custom training of various like chair classification or any AEC related object where you take a lot of objects from your site data or another kind of data, do custom labeling, and do a transfer learning where you take existing trained model and do a custom training for your own data set. And that's how you will be able to create your own uh, custom classification for your problem. So
Mm.
yeah, so various other data sets. So many times it's important to do a data set research because let's say if you're solving a problem of outdoor cityscape data and like outdoor bench or park or did some objects in park. So instead of going to different parks, taking images, labeling it, there might be some existing data set which already have taken those kind of images and labeled it. So it's important that you are aware of different data set currently available, so you can see and like do custom training on those data sets according to your needs. So as you can see, you can do scene classification, this is semantic segmentation, room layout detection. So a lot of it depends on what kind of problem you want to solve, and then identify the deep learning models available and connecting it with the existing data set or custom data set depending on your intent. So, do you have any problem just for discussion which you want to try to solve through this model?
So I was actually thinking along the lines of interior design, where we'll take an image, we'll understand what the scene is, we'll understand which objects are where, and we'll create that as a 3D model. Uh, and we'll extract what rotation the chair is, where it is exactly from the door, from the window, and we'll create a 3D model using it.
Oh, I see. Yeah, and actually that's a interesting problem. And I think I have seen one or two model where they're applying 3D reconstruction on interior images, interior data. So
uh,
if I get it right, ultimately, like if I'm entering a room, I'll take few images, and based on those few images, I'll be able to generate a 3D model of chair, furniture, walls, everything, along with classification. Right? That's the intent.
yes, yes.
Yeah, yeah. I think there are few models which you can definitely deploy it because people have done data set for interior images and deep learning models for those. So yeah, I'll get back to you if I find some good models for your problem.
Sure.
Good. Okay, so this is an overview of object detection and 3D reconstruction. And I just wanted to skim through it if you want uh, more detailed. Okay. This was started in 2004 with face detection algorithm, which is Euler Jones, and then various features are extracted. So, are you aware about how convolutional neural network works? I can
I,
quickly.
I took a course in college. Mhm.
Sorry.
Yeah, yeah, I know. I have basic
Okay.
idea.
Oh,
Took a course.
you know. Awesome. Yeah. So basically, in those CNN, you apply like different features like edges, line,
Mm-hmm.
rectangle, and then you
Yeah.
form relationship between eyes, nose, and various objects, and then ultimately you define whether it's a face or not. So it started in 2004 with faces. Then this is HOG. The popular model later got was LXNet, which is image classification model. And as we discussed earlier, it just detects the dominant object in that image. So it will say whether it's a shape, and it just gives a text output.
Hmm.
Then these are VGGs, where it got more, the network got more deeper. It's 22 layers, so it's a very heavy model. Then region-based RCNN, where we take input image and also like focus on those uh, region of interest and do image detection, bounding box on those. So it's pretty efficient rather than looking at the whole image.
Hmm.
Then we have YOLO. So
Hmm.
basically, how YOLO works is you break the image into different grids, and
Yes.
then you focus on one grid whether there's an object in that grid or not.
Yes.
And so what you will do is you define various scale of grids. So for example, if I have a smaller grid, I would be able to extract smaller objects from those exercise. And if I have a larger grid, I'll be able to identify whether a
Larger.
object is present in that grid or not.
Yes.
So that's YOLO.
Yes.
And basically, the difference between YOLO and SSD was many times it, how to say. So if the object doesn't fit into the grid, or if it's half in this grid or that grid, it became a challenge where how to train it. And so that's why what they did is they broke down the image into different scale of features. So I don't know if they have it here. So in this, uh, so in YOLO, basically there is a backbone model and there is a head model. So backbone model is existing uh, pre-trained image classification model. It can be LXNet or something. And basically that LXNet will give you what is the dominant object. In SSD, so they broke, like this is VGG, they broke the objects on different layers. So if in convolutional, like depending on which layer you are observing, there are high level features or low level features. So in basic CNN detecting faces, the initial layers will give you eyes or noses, and ultimately in few steps in the network, you'll be able to identify the whole face. So that's why in SSD, like the initial layers were able to identify the smaller objects, and the later layers were able to identify the larger objects. So hence
Mm-hmm.
they did CNN on each layer rather than the final output.
Hmm.
So once we do that, now, yeah, so we have different NN, DNN, and these are multi-object tracking (MOT). So what's the it has a different challenge because now we are not only tracking, like classifying objects in one frame, you are then monitoring what's the movement of those objects in in sequential data. So basically, if the is at this location, then you track either what are the coordinates of those objects with time, and there are various other challenges then which comes into place, that frequent occlusion where there are two objects and now one object is in front or behind of another object. So in MOT, what were the challenges? Yeah, so this gives a good overview about what are the various aspects in MOT. So first, appearance, and you track the motion, interaction between various objects, exclusion. But I think like if the problem you're solving is so the interior scale, I think the objects are mostly static, so you can deploy any of the this model. And I think maybe RetinaNet would be a good model to look into for your problem.
Okay.
Hmm. All right. So we discussed a lot of technical stuff. So let's do some fun exercise. So
Sure.
this is one uh, model. What they did is based on just one image, they are able to create the full human body in 3D model. So, mm, so this is on video, and yeah. So this is just your input image, and this is the output of that model. So initially, I thought, wait, how can it model the back side of the photo or the side of that image and create a 3D? But
Mhm.
like on the training, they trained on the data set was labeled and trained in such a way that it was able to figure out the side and predict what would be a depth and the back of that whole model. So let me share you the link. Okay. And you can click on this collab code, and I hope it works. And yeah. So basically, they have shared a collab implementation of their model. And in the beginning, you do change it to GPU. Um, Either you can run this model on your image or the existing data set. So, have you used Colab before?
Yes, yes.
Okay, yeah. Then yeah, it's super intuitive where you just play all the requirements. So I think I already cloned that data. So yeah. So you clone the model which they have shared from GitHub. Then this code works on if you want a custom input image, then you can run this button. Then we'll just import one file. So one thing to note is it should be PNG or JPEG format. I'll wait for a few seconds. Mm, Are you developing like a Android app for that?
No,
In,
we are right now experimenting. Right now, we are doing a service model at Pillar Plus. So, which means, no requirement of an app. Everything is web based or scripts right now before anything gets converted into a product later.
I see. And like, how are you getting the data? So if one is going at the site, are they like from the camera? It's going to the cloud, and you're
Yes.
computing. Oh, I see.
Yeah. Our site managers do that.
Hmm. Yeah. So one thing to keep track or be aware is like the possibilities are like very promising for upcoming Apple models where using
Yeah, kit.
A- yeah AR kit and the LiDAR camera, we can build all those point cloud and segmentation within few lines of code. So yeah, and
Oh,
I have seen like one app already where it was used like generating all the point cloud data and 3D model just using few lines. So it might also save a lot of your time, but then it comes with a limitation that a person needs to have a lidar based camera to implement this.
oh, so I just shared a link. I think this is from this current YC batch. Probably they must be using this only.
Oh yeah, yeah, I have seen this, and so if I'm not wrong, it's 2D data, not like it's basically doing object detection and then transferring that data from phone to your laptop.
To a laptop.
Yeah, yeah, but it's using a computer vision model for identifying what's the dominant object in that frame and extracting that. So so ultimately all this data is in numbers like RGB metrics. So yeah, yeah, but this is a cool tool.
Yeah, so pretty nice tool. Current YC batch.
Yeah. And things will go very strong because like ultimately if we don't do something, then either like people from other industry will do it. So
Yeah.
yeah, I think it's a right time where like you guys are focusing on this because within 1 or 2 years there would be many models or companies getting into this area.
Okay. This can be super helpful in interior design where like architects, find use Pinterest images to find things and then they tell their clients ki isme sahi hai, isme sahi hai. Like this can help them create mood boards very fast.
Oh, you, you know what? Like it it would be really cool if you can combine the feature of clip and 3D reconstruction. So basically, as I said, from Pinterest, I can just select an image
And it
and
gets
I can paste it in the 3D model and reconstruct a 3D model. So these guys are doing in on human bodies, and
huh.
maybe you can do it on furniture or like based on single Pinterest image, you place a 3D model on. I don't know.
This becomes a total disruptor then, for sure.
Yeah. So I know what's the popular furniture company. IKEA did an augmented reality platform where they were placing different furnitures from their catalog
It was a
in.
simple AR application where you can select a model and then they'll
Mhm.
uh, place it, you can place it in any scene.
Yeah, that would be like a typical AR application. But yeah, I think that if the intent is to try out different objects in interior, then yeah, having like hands-on image extraction and placing it in reality would save a lot of time. And also, like,
Yes.
if I was reading more about ARKit, that you can apply even different lighting conditions. That is something unique value, which if you played, if you place just a static image versus a 3D model with different lighting features, you can you can see how the objects are behaving with different artificial or sunlight over time in interior scene.
Huh.
Yeah, so I think let me disentangle uh, interior scene uh, deeply. Mhm. Yeah, I think this would be helpful, Gen 4, but um, what this guy was doing. No, this is CAN based morphing. I saw one image where they were manipulating the light as well. Maybe this harmonization look like. Yeah, I'll get back to you on this because I saw uh like imagine like this as an interior model and how uh you have the sliders to vary the parameters of orientation. So there was one slider for lighting where they were able to like do a daytime or a nighttime simulation of that interior scene.
Oh.
Yeah. So yeah, you can refer to this website. Basically, it's disentangling of GAN. So if you train a GAN network on various interior images, which has some images have natural light, some images have dark artificial light. So the network then learns how, for the same image, different lighting conditions affect the shadow and the room aesthetic. And
Hmm.
then, based on all the training data, you're extracting the parameter from that data that, okay, there is something called a lighting parameter, which is affecting different conditions in the training data.
Hmm. Uh,
Let me share it in the chat. Cool. Okay, it's 11:40, and I'll just conclude by this implementation. Do you have access to this collab?
I'll check.
Okay. Yeah, I think like the point I wanted to communicate was that you can do create 3D models just from the images, and using this, and I'll share. A while ago, I did in November. Yeah, so this was my input image, and it was able to create 3D model just from that. So that is the script. Okay. And one thing before we conclude this is also keep an eye on Nerf, so which is like groundbreaking research happened in 2020. Not this one. Um, so it's a totally different approach of doing image reconstruction and multi-view projection. The resolution is so smooth, as you can see here. I'm not sure if they have the code. Yeah.
Okay.
So yeah. So basically, like the the concept is you use multiple view images to construct a ray, and then you project different view images on these nodes from other images. Maybe I should do a implementation of this. It would be interesting.
Okay.
Yeah. All right. So we discussed the theory. We saw a few important models to keep an eye on, and even I'll share this tiny. So basically, this is a small version of that model which I found to do on this object. Even let me share that. Cool. All right. So, so generally, like in the end of each session, I do a discussion where what where some aspect from this uh, uh, theory we discussed today, which we can apply on AEC.
Mm-hmm.
And you, like you pointed out, that you are planning to solve the problem of interior scene reconstruction using which can use these techniques. Do you think any other area in AC uh, which would be useful, like to deploy using this solution, and that problem can be solved?
So one is like site inspection, site tracking. So if we could, have say a person walking around the job site, construction site with a camera, and with some camera that'll automatic, and it will automatically translate whatever the camera is seeing into 3D, so that any person outside can judge the work progress and do inspection.
Oh, I see. Yeah. Let me share one. So this is one amazing presentation prepared by Columbia, and I wanted to. It has a bit blurry resolution, but I wanted to showcase that it's for planning, design, supply management, autonomous equipment, quality inspection. Like a lot of these machine learning models have computer vision techniques in
Yes.
those.
The
Like,
reason this is important is because like a lot of construction happening in Middle East, a lot of construction in Australia, US, so they outsource their Revit work to uh, companies in India. Now
mhm.
they have to like send consultants there on a regular basis, which all of that expense could be avoided if those consultants can actually see everything in 3D real time.
Oh, I see. Yeah, actually, I never thought about that. Like, because a lot of people do outsourcing, so
Yeah.
many times they do changes based on the photos or the site report they send. And
Yeah.
few of the sorry.
I am in touch with a lot of consultants who actually need this. A lot of companies who would actually, be willing to try this out if they have such a solution where they'll have to, where they can save money on sending people to the site again and again.
I see. So if I get it right, they are interested in how. they can send their people on site, take several photos, and a 3D model would be constructed, and that 3D model is shared with the outsourcing people.
Yes, yes.
Oh, I see. Yeah, because there are few companies who are deploying like a site-based camera where they do inspection,
Hmm.
and few companies, uh, but like I have seen on either one or two companies where they're doing like beam clash detection, where they do like the concept of digital twin, where they have the existing model or like existing building, they convert it into a digital model and compare it with their actual model. So what are some deviation? But I need to know like how they are doing the digital twin process.
Hmm.
Hmm. Yeah, even like there are good applications in uh, construction site safety, whether workers are wearing PPE, helmets, or anything, because generally a lot of safety managers, they do site inspection, but then the workers know when they are coming, so they'll wear during that time, and then once they leave, they 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 follow less rigorously. And another way to solve that technique is using on-site camera, but then also it comes at some privacy. So
So that then should be applied to colleges, schools. Like my a friend of mine has a factory where he has a lot of tailors stitching his clothes. So he wanted actually to track them, that whether they
hmm.
are actually on their desk or not, or whether they're on their desk but working or not. So these things can be done then, because he pays them on a per hour basis. So something, this solution of this sort is important for him.
Yeah, and yeah, and also looking at manufacturing scale, because these models are able to identify the edges and corner points.
Hmm.
Maybe one can also detect the deviation in like whether the thickness is right or how much deviation in the actual thickness.
Hmm.
Or even if like let's say I'm installing a interior partition, and if it gets bent or there's some corner damages, I can see whether a person has installed that properly or not and identify those corners.
Hmm.
Cool. uh, it was a nice discussion.
Yeah,
Hmm.
yeah. And how is it, like how is that thing going on, a generation of floor plans?
Oh, the GAN.
Yeah.
So uh, I had this did I show you the GAN model of floor plans where it was able to generate that uh, animation of floor plan?
Yeah, yeah, I have seen that.
Yeah,
You
so
posted on LinkedIn, right?
sorry.
LinkedIn one, bro? No, you posted on LinkedIn, right?
uh yeah, it was like a while ago, 2 3 months ago.
Yeah, yeah.
Yeah,
So
so yeah, go ahead.
a company recently asked me this, that whether you guys are doing this or not. So they do a lot of interiors and architectural planning. So they were, trying to do this experiment, that this is the area I need five co-working, five desks, say five cabins of this size. So it should generate some plans.
Yeah, so after that, so there were two challenges with that application, and because it was able to generate like good morphing interior plans, there were I had limited control on like if there is a particular image and I just want to change dimension of one particular room, that thing that model was not able to do. So as I discussed briefly at the start, so those type of style can animation have entangled uh, entanglement in the variables, which means that let's say if I have a model which is morphing different faces, if I
Hmm.
change one value, it
Hmm.
and I can't control whether it changes hair, eye, color of the skin. If I
Hmm.
change one value, it will change every values in some manner. So that's why when I was sliding on that floor plan, if I slide a bit, it will change every room by one, like some aspect. So that's why what people do is take those entangled variables and disentangle it, where after that processing, each variable will correspond to one aspect. So that's why when you see like that those sliders on the model where you slide one value and it changes the length of the hair or color, those models are disentanglement. So I was thinking of applying a disentanglement on those flow plans. But then I came across this paper on house gain where they were using graph neural network. And
Hmm.
the advantage of the graph neural network is you maintain the relationship exclusively. So
Hmm.
I can say what different rooms I want by this nodes, and I can also define the connectivity between those rooms via this edges. So the style gain in model when I do descending, there is a possibility where it will place entry in center or bathroom at some weird place. So using this constraint based deep learning model applied via graph, the floor plans here makes a lot of sense where the connectivity is logical, the different layout generations makes are realistic. And so this is deployed by Autodesk, and they also have a collab code. And I think in either first or second live stream, like we did a discussion on this. So as you can
Yeah.
see, yeah, just this is just CNN, this is graph CNN, where now you can see the difference where the layout is making more sense in connectivity.
Hmm. Also, how do you think about this idea of, like, suppose I want to buy, suppose Tesla builds cars, so it plans its model just once, like the design is done once and it is repeated again and again to make thousands of cars. iPhone makes one phone, designs one phone, and then it's repeated like a million times to sell to different people. But for houses, we always design the house from scratch. We are designing the floor plan, then we're designing its interiors, then we're designing its structural drawings, we're designing its HVAC drawings, firefighting drawings from scratch. Everything is done from scratch, always for a house. So if we are, do you have any, thoughts along this line that if we have, say, we have a house that has already been built for an 8,000 square feet area, and now we want to extrapolate that to 10,000 square feet area, or say reduce it to 6,000 square feet area? Any things, any tools, or any techniques that can help us do that while preserving such high complexity of data?
Yeah, so like I am seeing like in past few years on the popularity of like using product management principles in architecture design, where yeah, as you correctly pointed out, how cars and iPhone do.
Hmm.
So one way to which people are solving is using kit of parts. Imagine like a Lego blocks, like
Using.
a kit of parts. So it's called a discrete architectural style. I'll show you.
Okay.
So if you see Wikipedia or WikiHow or something. So basically, what you deploy is different sections uh, to build a house. So let's say beam, column, and give the flexibility to the user to do like various uh, room layout options using that kit of parts. So one can generate any number of house layout using this like 4 to 5 kits. like 4 to 5 components.
Mhm.
So basically, the role of the designers then becomes how to design these components or kits through which a user will be able to generate and customize their house. But it's also a discussion topic where like people are fine to have a car which is standardized, but people want some personal touch in their room or housing where they call it their own. So a combination of standardization plus customization would would be a good approach.
Huh.
Yeah, yeah, it's a challenging problem to solve. Where how can we make a product based approach in architecture? So yeah, people like even this house. It's called discrete architecture style, where you deploy this components and either the designer can share various iterations or leave it to the end user. Cool. Uh, so I'm gonna end the live stream